So here's what we know about subatomic particles that exist in the atom now. We have a nucleus in the atom, thanks to Ernest Rutherford and his gold foil experiment. And since that time, we've discovered that the nucleus contains two different subatomic particles. One is called a proton, and this proton carries a positive charge. And the other particle in the nucleus is called a neutron. And as you can tell by its name, neutrons contain neutral charges. So those two sort of live together inside the nucleus, and they're the most massive. They're about equal masses. Then we have electrons outside the nucleus, which orbit around it, and those contain negative charge. So all in all, the atom itself is neutral in charge because the protons cancel out the electrons. Most of the atom's mass is contained in the nucleus, but it's still a very, very small area. The number of protons in the nucleus of an atom is what we call its atomic number. And you can find the atomic number on the element symbol on any periodic table that you look at. For example, the atomic number for hydrogen is 1. Hydrogen atoms all have 1 proton. The atomic number for helium is 2, because helium atoms all have 2 protons. Carbon is 6, oxygen is 8, neon is 10. That's what determines what element an atom is going to be, by its number of electrons, or number of protons. The number of protons determine what element an atom is going to be. And if you change the number of protons, you change the element. The electrons and protons are equal in neutral atoms, as I mentioned before. In a couple chapters, we'll talk about ions, where they're not equal, and so you have a charged atom. But for now, they're all going to be equal. And in the last 50 or so years, we've learned that protons and neutrons are made up of even smaller particles called quarks. Not very important to us right now in beginning chemistry, but later on they will be. So here's a chart of electrons, protons, and neutrons. You do not need to know the masses of these particles. What you do need to note, though, if you look here at the mass for neutrons and protons, notice they're about the same. That the mass of a proton is about equal to the mass of a neutron. And these, one of these two, a proton or a neutron, is about 1,000 times as massive as an electron. So it would take about 1,000 electrons to equal the mass of 1 proton or 1 neutron. The charges, make sure you know those. Electron has a -1 charge, proton's +1, neutron's neutral. But the mass numbers you do not need to know specifically, but know their relative sizes to one another. And then also know where they're located in the So the atomic number indicates the number of protons in the nucleus of an atom. The mass number indicates the number of protons plus the number of neutrons. The mass number is not located on the periodic table. So in order to determine the mass number, we have to know how many neutrons are in the nucleus. This number is always a whole number, though, as is the atomic number. And like I said, it's not on the periodic table. So if we look at the diagram, you have a carbon atom, and carbon atoms all have 6 protons. This particular carbon atom also has 6 neutrons. So we call it a carbon-12 atom. And that 12 written after the carbon is the mass number. And it tells us the number of protons plus the number of neutrons. Now we can always look up on the periodic table and determine how many protons a carbon atom has. We know it has 6. So we simply take the mass number minus the number of protons, and that'll tell us the number of neutrons. We also know that the number of electrons is going to be equal to the number of protons. So that's also going to be 6. So the atomic number of an element is the number of protons in the nucleus of an atom. And that is exactly the same as what you'll see on the periodic table. As you move down the periodic table, those numbers get bigger. That means the atom gets more massive as well. And here's just a table just comparing some random elements with their numbers of protons and the corresponding atomic number. The mass numbers, the number of protons, plus the neutrons in the nucleus. And different numbers of neutrons give us what we call isotopes. And isotopes are atoms of the same element that have the same number of protons but different numbers of neutrons. Let me say that again. An isotope are atoms of the same element that have the same number of protons but different numbers of neutrons. So let's look at this chart up here, and we're going to fill it in. Based on the information that's given, we're going to fill in the missing information. So the first one, we have an oxygen atom. And this particular oxygen atom has 10 neutrons. Now we know by looking on the periodic table that all oxygen atoms have 8 protons. And so if this oxygen atom has 8 protons, then we know it must have 8 electrons. And so we know if it has 8 protons and 10 neutrons, that it has a mass number of 18. So this is what we call an oxygen 18 nuclide. There are 3 isotopes of oxygen. There's an oxygen 16, which is the most common, an oxygen 17, and an oxygen 18. And this is an oxygen 18. And then each individual isotope we call a nuclide. So how about this next one down here? We have an element with 33 protons. That's going to tell us that it's an arsenic atom, because all arsenic atoms have 33 protons. For this information, we have to look on the periodic table and see which element has an atomic mass of 33. So we know then it has 33 electrons, and because it has 42 neutrons, we take 33 plus 42, add that together, and we get a mass number of 75. So this is an arsenic 75 nuclide. The last element, 15 protons, and we know it has a mass number of 31 because it's given us that mass number over in the nuclide section. Therefore, we know it's a phosphorus atom because it has 15 protons. Now, it has a mass number of 31. 15 of those are protons. That means we have to have 16 neutrons, as well as 15 electrons. So the number of protons plus the number of neutrons always equals the mass number. The number of protons always equals the atomic number. That number we can find on the periodic table. And the number of protons also equals the number of electrons. As I said before, isotopes are atoms of the same elements with different mass numbers. And another way that we can write those is by writing what we call a nuclear symbol. As you see over on the right, this is a nuclear symbol for the carbon-12 atom. We simply write the mass number in the upper left-hand corner and the atomic number in the lower left-hand corner. This will tell you the number of protons and the number of neutrons in the nucleus of that carbon atom. You can also write it as a hyphenated notation, as you see down at the bottom. We would call this simply a carbon-12 atom. So a couple different ways to write out isotopes using the mass number. And these are some pictures of a carbon-12 and a carbon-14 atom as they would appear in the nucleus if we were able to blow up that nucleus and look at the protons and neutrons in there. And see, the difference between the carbon-12 and the carbon-14 atom is the number of neutrons. A carbon-14 atom has 8 neutrons, carbon-12 atom has 6 neutrons, but they both have 6 protons. That's what makes it carbon. So let's look at this slide. Chlorine-37. Here's what you should be able to do. Look at this notation, chlorine-37. Can you identify the atomic number of chlorine? To do this, we'll look at the periodic table. Chlorine has an atomic number of 17. So that means it has 17 protons. Its mass number is written right there next to the element, 37. So if it has an atomic number of 17, that means it has 17 protons. That means it has 17 electrons. The number of neutrons is going to be the difference between the mass number and the number of protons. That's going to be 20. And so we could write the nuclear symbol like you see in the lower right-hand corner. This would be a chlorine-37 atom. Remember, the top left number is the mass number, and the bottom left number is the atomic number.